to today's chemistry class. So, how are you all? Yes, all are keeping good, right? Yes. So, I wish that soon this COVID situation ends and meet you in personal in our school. So, let's hope for the best. So, are you all studying from your home through the online classes? Are you enjoying the online classes? Yes. Somebody is telling yes. Somebody is telling no. Yes. Anyway, we have to study. Our education system is progressing. So we have all the facilities like online platforms we are having, video recording platforms we are having. So we have all the facilities to study. So every student should study and achieve high in their future. Okay. So today we are going to study about colloids, true solution and suspension. Okay, what are we going to study? We are going to study about true solution, colloids and suspension. Let me write true solution. True solution. The other one is colloid. Colloid or colloids and suspension. Okay. Now, before moving into all the three, let us pick out each one separately. Okay, let us pick out each one separately. Now we are going to see about true solution. True solution. How does a true solution is obtained? Okay, let us take the example of this sugar solution itself. We are taking a glass of water. To that we are adding some sugar. We are dissolving completely. Now what happens? Yes, the sugar get completely dissolved inside the water, right? Now it is a sugar solution. It is a sugar solution. It is a true solution. Why it is called true solution? Because the sugar particles completely dissolved in it. It completely dissolved in it. Okay, so the particles get completely dissolved, and there will be a uniform composition also. There will be a uniform composition throughout the solution. The properties will be same. If you are taking what molecules of this sugar solution also will get the same properties. So there is a uniformity is there. Okay, so uniform dissolution is there. The other one is the size, the particles which are present in the sugar solution, no, the size is less than 1 nanometer. It is less than, size is less than 1 nanometer. The size of the true particles in a true solution is less than 1 nanometer. Keep in mind, okay. So, now it is completely dissolved. It has uniformity. The size is less than 1 nanometer. Now, if I am passing a beam of light through the true solution, will the path of light can be seen or not? Can we see the path of the light? No, we cannot see the path of the light because the particles are very small. There are no particles inside this true solution in order to scatter the light. Okay, so we cannot see the path of the beam of light. Path of the light cannot be seen. Path of light cannot be seen. Cannot be seen. And what about the filtration? Yes, the true solution cannot be filtered. Cannot be filtered because we cannot get a filtrate and the solute because it is completely dissolved. This is about true solution. Once again, it is completely dissolved. Uniformity is there. The size is less than 1 nanometer and the path cannot be seen. If we are passing a beam of light, the path cannot be seen and it cannot be filtered also. It cannot be filtered also. Okay. Now let us study about colloids. Okay. Let us study about colloids. Colloids. Before that, let us study about suspension. So that study of colloids will be easy. Okay. Suspension means size is greater than 1000 nanometer. Its size is greater than 1000 nanometer. Okay. Here the particles can be seen. Particles can be seen because the particles are little bit bigger sizes. So because it is greater than 1000 nanometer, right? So particles can be seen. Particles can be seen. Now, one more thing is, it is not having a uniform distribution. When it is kept as it is undisturbed for some time, it will get settled down. Solute will get settled down. Solute will settle down. Now, if we are passing a beam of light through a suspension, of course we can see the path of light because it is having the particles in it, right? Particles are of greater than 1000 nanometer. We can see the particles also. So these particles scatter the beam of light. It will scatter the beam of light and we can see the path of the light. You can see path of light. Okay. Now, one more thing what you have to see is, when it is kept undisturbed for some time, it will settle down. The solute will settle down. The solute will be settled down. Once again, let us see about suspension. It is greater than 1000 nanometer. Particles can be seen. Solution will settle down if we are keeping undisturbed for some time, and the path of the light can be seen. You can see the path of the light also. Now, by studying about suspension and by studying about the true solution, we can study about colloids. The study will be easy. That is, the size is between 1 nanometer and 1000 nanometer. The size of colloid is between 1 nanometer and 1000 nanometer. Here also, the particles cannot be seen. Okay, particles cannot be seen. But these particles have the capacity to scatter the light. They scatter the light. They have the capacity to scatter the light. They can. Colloids can scatter the light. Next, when it is kept for some time undisturbed, it will not settle down. It will not settle down. Okay. When it is kept undisturbed, it will not settle down. It will not settle down. This colloids also cannot be filtered using normal filtration. Colloids also cannot be filtered. Cannot be filtered using normal filtration. Normal filtration. These colloids also cannot be filtered so easily using normal filtration. Now, we have discussed about true solution, colloids and suspension. Right. Now, just watch a video and come back. Here is a video for you. Watch it clearly, perfectly and come back. Enjoyed? Yeah, in this video, it was completely explained about true solution, colloids and suspension. Now you don't have any doubt, right? Yes. Now I am going to give you an activity, that is, what you have to do is make the properties, like you have to write the column like true solution, colloids and suspension. And now what you have to do is you have to write the same, whatever properties I am telling you have to write. Okay. The first point I am asking you, write about scattering of light. Scattering of light. The other thing you have to write is about filtration. How can we filtration? How can we filter each substance? You have to write that. The other thing you have to write is about the settlement of particles. Settlement of particles. Okay. Now itself we have to open your notebook and write about the scattering of light, the settlement of particles, and about filtration in case of colloids, in case of true solution, and in case of suspension. Now itself, right? I'll be giving you 5 minutes. Yes? I hope all of you have written the answers. Now, let us discuss the answers. Yes, the same thing we have discussed is scattering of light in true solution will not take place because it is a true solution. The dissolution is complete. And in case of colloids, it will take place. It will take place because there are little particles, small particles which has the ability to scatter the colloids. And in case of suspension also, the scattering of light takes place because they are having large sized particles like now. So that is why there also the scattering of light takes place. Now we have to see about filtration. This true solution cannot be filtered easily. We have to use some techniques to filter. Likewise, this colloids, true solution cannot be filtered. Colloids also cannot be filtered. We have to use some kind of centrifugation techniques, ultrafiltration techniques in order to filter the colloidal particles. And also this suspension. The suspension can be filtered easily. Suspension can be filtered easily using normal filter papers. Okay. Now coming to the next point. Settlement of particles. Settlement of particles. In the true solution, settlement of particles don't take place if we are keeping still for some time. There is no settlement of particles. But in the case of colloids also, no settlement of particles. If we are keeping undisturbed for some time, no settlement of particles takes place. But in case of suspension, if we are keeping undisturbed for some time, we call it as there will be some settlement of particles. Okay. Now hope all of you have understood about suspension, true solution and colloids in detail. Okay. Now coming to the heading colloid alone. If we are planning to learn about colloid little bit more, let us see. Colloids. Here I am showing one video. Please watch the video and come back.
What is colloidal solution? The colloidal state of matter was first introduced by Thomas Graham in 1861. He divided the substances into two classes depending on the ability of diffusion. Colloids are the substances which cannot diffuse through the colloidal membrane or parchment membrane, for example, starch, gelatin, etc. If the particles of sugar are dissolved in water, a homogeneous solution, that is true solution, is obtained. The particles in true solutions are too small. approximately 10 to the power minus 9 meters, to be seen with the naked eye or even under the microscope. On the other hand, if a little clay or sand is mixed with the water, a heterogeneous mixture, suspension, is obtained. The particles in suspension are so large, approximately 10 to the power minus 7 meters, that they can be visible even with the naked eyes. Particles in the colloidal state possess the size between that of the particles in the true solution and particle in suspension. In other words, the size of the colloidal particle lies between 10 to the power minus 9 meter and 10 to the power minus 7 meters. The colloidal particles form the dispersed phase. The medium used for the dispersion is called dispersion medium. The dispersed phase and dispersion medium together form a colloidal system. The dispersed phase and dispersion medium may be solid, liquid, or gas.
Yes, have you seen the video of colloid? Yeah, in colloid, there are two terms we should know. The first term is dispersed phase, dispersed phase, and the other term is dispersion medium, dispersion medium. We have to know about dispersion medium. Okay, dispersed phase means the substance which get dissolved in the dispersion medium. If this one is the dispersion medium, the substance which get dissolved is called dispersed phase. So, the dispersed phase get dissolved in the dispersion medium. Once again, dispersed phase get dissolved in the dispersion medium. That is about colloids, and the further the separation of colloids, separation techniques of colloids and all we will discuss in the next class. So here I would like to give you an assignment. Take your notebook and write the question. Prepare a note on true solution, suspension and colloids. That is the first question. The second question you have to write is prepare a note on dispersed phase and a note on dispersion medium. Okay, that's all for today. Thank you for listening. See you in the next class. Bye for them. Bye.